Hello everyone. In this series of videos, I'm going to give a brief introduction to the field of game theory. The idea here is to give you a basic understanding of the terminology and techniques of game theory that you could apply to models in industrial organization or managerial economics. You've probably heard the term game theory before, but you might not have a good understanding for what exactly we do in game theory. We'll first ask the question, what is a game? In the broadest sense, we define a game as some kind of model of a strategic situation. A strategic environment is simply one where each agent in the environment is aware of the actions of the other agents and reacts accordingly. Agents in the game are also aware that their own actions have an impact on the decisions of others. There are three main components that we need for a game. We need players, we need strategies, and finally, we need payoffs. Let's talk about the players first. What we specifically mean by players is going to vary by the game that we're looking at. We could think about a chess game or a checkers game where we have two players sitting on opposite sides of the boards. Although we won't specifically talk about board games necessarily, they still count as games from the perspective of game theory. Moving into an economics context, our players might be two competing firms like Coke and Pepsi. They might be competing oil companies or two competing grocery stores in your hometown. To talk about a game, we do need at least two players. If we don't have at least two players, we don't have a strategic environment. One player by themselves still has to think about what's the best decision, but they don't have to take into account anyone else's actions. So a Monopoly is not a game. We will start out with the simplest types of games that only have two players. But in game theory, we can talk about an n-player game, where n has to be at least two. But it could be 20 players, 30 players, any amount of players. Usually when we talk about a specific player, we talk about player I. We've used this terminology before, but it just refers to a generic player, where I could be 1 for player 1, player 2, all the way up to player n. Like I said, we are going to be focusing on two-player games to start out with. Next, let's talk about strategies. A strategy is basically a plan of action for a particular player. Our simplest of games have very simple strategies because there's only so many different options a player has. Next week, we'll get into more complicated games where there's an infinite number of options for a player to make. The simplest type of strategy might just say, I'm always going to do one thing. But a more complex strategy would take into account the actions of the other players. So we could say, if the other player does this, I'll do this. If the other player does that, I'll do that. A strategy could then build in contingencies for every single possible action of the other players. And as we get more and more players, the complexity of the strategies will increase very, very quickly. In the most general sense, we'll refer to a specific strategy for player I as SI. SI is not a number, it's not any one thing, it's simply their strategy. And it could be a very complex strategy or it could be a very simple strategy. Strategy SI is the strategy that player I has chosen, and SI has to come from a larger set of strategies that I'll call capital SI, that are all the possible strategies that player I could pick. Note that I've used this mathematical symbol here, and that means a member of. So capital SI is the collection of possible strategies, and the player I is going to pick one of those. The last thing to talk about are the payoffs. The payoffs are what players get out of the game once everything is done. Payoffs are what motivates the players. Different strategies might lead to different payoffs, and different combinations of one player's strategy and another player's strategy might lead to different payoffs. Payoffs are ultimately what determines the strategies that the players use. We'll denote our payoffs in terms of utility. Just like we did all the way back when we talked about consumer choice, the higher the utility, the more preferred the outcome. I will write player I's utility as UI, the utility that player I gets. UI is determined by SI, player I's own strategy, but also it depends on the strategy of all of the other players. and I'll denote this with S minus I. In game theory, when we talk about minus I, that means not I. So S not I is the strategy of everyone else who is not player I. Suppose we were looking at a 3-player game where we wanted to know what is player 1's utility. So we write U1. That, of course, is going to depend on player 1's own strategy, but also the strategy of players who are not player 1. So in this case, it's going to be player 2 and player 3. And this right here is our S not I. It's important to note that player 1 only has control over S1, whereas player 2 chooses S2 and player 3 chooses S3. So what this means is that in game theory, your own outcome depends on what other people do. And that's what sets our game theory models apart from perfect competition and from Monopoly. In perfect competition, each individual player was so small that they didn't actually have an impact on the other firms. And in Monopoly, there's only one player, only one monopolist. So they didn't have to worry about this either. When we analyze some example games in the coming videos, I'm going to be referring back to this structure, talking about who are the players, what are the strategies, and what are the payoffs. These are our 3 main building blocks of a game. Last thing I want to talk about here is just to come back to a concept that I brought up at the very beginning, which is this week we are going to be talking about simultaneous one-shot games. What does it mean for a game to be simultaneous? It means that the players are going to make decisions at the same time. Those players are not able to observe what the other players are doing. They have to make their decisions in isolation, essentially. They're not allowed to communicate with the other players. They have to make their decision completely on their own. Later on, we're going to talk about sequential games where one player gets to observe what the other player does before making their own decision. And that's going to fundamentally alter the way that decisions are made. We're going to start at simultaneous games. The games that we're going to look at here are also one-shot games. One-shot games are games that happen only one time and the players never see each other again. These types of games are contrasted with repeated games. In repeated games, players meet each other multiple times again and again over time. And that's going to fundamentally alter how the games end up being played. And we're going to talk about that in a couple of weeks. So to sum up, the games that we're going to talk about here are simultaneous one-shot games where players make decisions at the same time and they only do it once. These types of games are the bedrock of game theory, and many of the most famous games, some of which you may have heard of, fit into this category. Our basic oligopoly models that we'll be covering later also fall into this type of game.